Hello everybody. Let's talk about game state now. Game state has its name for a reason, of course. This is something that's going on in the background for the entire game. And it is an auto load under project settings. That's very important. That is not going to be demonstrable in the script anywhere. But if you go to project menu, project settings, fourth tab to the right, we'll have auto-loaded scripts. This will allow you to instantiate these scripts at the beginning of the game and make them global variables, which is what we want. There aren't really any circumstances in this particular game where I could see the game state not being involved. We have a default port here. I left this as the chosen one for the tutorial that I've effectively been remaking here and adding Steam support to. That's 10567 here. It can be just about whatever you want as long as it's not too large and is preferably above 2000. Technically it can be any number between 1024 and 49151. 10567 works great for us. Maximum number of players, it's set to 12. I'm going to leave that alone. We also keep a record of our peer here for the sake of clarity. I showed you in the last one how peer is set to an eNet multiplayer peer or a Steam multiplayer peer. And eventually multiplayer.multiplayer peer is set to this once we've configured it. So this is purely a utility field at the moment. We have a name for our local player. This one is on the edge of what I would usually allow in game state, but it is very important for, say, setting up network connections. One of the downsides to GD script that still irks me a little is dictionaries can't be described with further type format. I can't declare players as a dictionary of ints to strings, but we can use it that way. For that reason, I normally recommend annotating it with a comment and simply describing what it is that it's supposed to be. Then hold yourself to that. Players ready is simply a list of players who are ready to join the game. Lobby ID is set to -1 because 0 often has special meaning here. Eventually it'll be our Steam lobby ID if we're using one. If it's an eNet connection, we won't touch that again. Now we have our signals again. I remind you that their player list changed, which is what happens when a player joins or leaves. Connection failed, connection succeeded, game ended, game error, and game log. I like to have error and log separate because you might log things which are not technically errors, and hypothetically there could be some types of errors that aren't logged, though they're not common. I usually want to hear about that. In any case, it feels like two different operations to me. So, ready. Once again, Steam init X, and we are using 480 for this one, which is the one that's open for testing. As a reminder, retrieve stats is almost always going to want to be true. That enables a lot of the extra features for Godot Steam. And then after that, you would provide your game ID. There are a number of other ways to do this too. This works for me though, so that's what we're going to be doing for now. Once again, we've got a number of signals I am connecting right here in ready with Lambda functions, just so we don't have to go chasing across our code. For peer connected, we just register our player, ID and player name. Excuse me. For peer connected, we call RPC ID here, which is different from a normal RPC call. The ID parameter that is being passed is the peer ID of the connected player. This is one case where we actually do need to keep track of these serial numbers, though again, that doesn't mean you need to look at them. And for the love of God, don't do math on them. But this is valuable here because we also want to know that let that player know that we, as the host or another client, have also connected. So we call register player on them. Register player is an RPC annotated call. So we call RPC ID, their ID, and our player name. In fact, let's look at register player now. So, what register player does is it takes a new player name, gets the ID of the remote sender here, which is something you can query from this in an RPC call, and set players by that player's peer ID to be their name. Make string unique is a simple utility function I wrote just to ensure that we don't end up with multiple players with the same name, as that kind of scrambles the old scoring system. Then lastly, we emit player list changed so that the list of players updates. RPC requires a little bit more description here. You will notice that in this instance, not only do we have it annotated as RPC, meaning that this is allowed to be called by other machines, we have it further described as call local and any peer. There are a number of parameters you can pass into this. Any peer could also be authority, which means only the server or host can call it remotely. It won't allow it from anybody else. Any peer means any client can call it remotely, which is really good for, say, cases like this, some things with user input. If you violate these, so you know, the system is going to reject this call and possibly throw an error. Just to say something's going on here that either you didn't mean to write, or worse, you didn't write and somebody's trying to exploit your game or cheat. Call local allows you to call it on the local peer. This is an interesting one. If the server is also a player, or in other words a host, then this is very important. But if you want to restrict that, which is often the case, you would do call remote. And then an RPC generic call, which is called on every player, will not be called locally. It'll just be on everybody else. Calling it directly if it's an RPC is usually a design flaw or indicative of one somewhere. I would take a look at that. Transfer mode is the other possibility here. That can be three things. There's unreliable, which is where packets are not acknowledged, can be lost, and can arrive at any order. Why would anyone do that? Because it's much, much faster if you don't have to worry about the overhead. Unreliable ordered is almost unreliable, but they do have a guaranteed order. However, you will note that if they show up out of order, you'll lose the whole thing with unreliable. It doesn't worry about criticality with it. The last one is reliable, which means that resend attempts are going to be sent over and over again until the machine is absolutely certain that the package has been acknowledged. And the order will be preserved here. Now, that sounds great, but there's a significant performance penalty on it, and for a lot of what we're doing, we can usually interpolate if there's packet losses. They're not uncommon things. They happen all the time, even in places with good connections. Maybe a power line's down. You never know this stuff. The last possible flag on it would be an integer, which is the channel index. Usually it's 0 here. I don't think it's necessarily going to be that important for us in this particular tutorial. And again, multiplayer.getRemoteSenderID can be used to get the unique ID of any RPC sender when used within a function that is RPC annotated and called properly. So to do that, we do registerPlayer.rpc and then the parameter. The important thing to remember about them is they are technically void functions, so if I had this returning something, it would be totally lost. You'd have to use a synchronizer for that. And we'll come back to synchronizers in a little while. But this is what register player does. You call it on other machines. It takes your peer ID and assigns a unique and, for the record, deterministic string to your player name based on the player name you've asked for, and then emits the player changed. Unregister is very similar in that it erases you from that and then emits another player list changed. And that's all it has to worry about. In fact, there aren't even any occasions when we strictly need to RPC unregister player, although I'll admit I may have overlooked something. So let's head back up. Now that we know what register player does, which basically means let everybody know this guy is connected. For peer disconnected, if the game is in progress, and that's a utility function that does a few checks to see whether or not the game is in progress. It's very specific to this one, but I do encourage you to have something like that and keep it simple. And we are being called by the server. A game error is emitted here. Now, this was the fashion established by the first version of this, which I've preserved here for the sake of simplicity. I don't know that I agree that the player disconnecting qualifies as a true error. This feels like a log message, but presentation and brevity is more important to me than getting everything technically correct here. And then end game is called, which does exactly what it sounds like, really. Takes you back to the lobby, effectively. Otherwise, we simply unregister that player. It doesn't need to be called for the server because the whole list is cleared anyway then. We're all connecting to the server. But if it's just a single client that dropped, then we can just unregister it, which means clear it out and get rid of it, and then go ahead. So, connected to server. This is what happens when we have connected to the server, not when we're attempting it. It simply emits the connection succeeded signal that we defined above. If connection failed, the first thing and the most important thing for that to do is to reset our multiplayer peer to null. You could, in theory, also use offline multiplayer peer here. I'm going for brevity. Then it emits connection failed, so we can handle other problems up the road. The important thing to remember is we don't know if this is over Steam or eNet or anything else you should decide to enroll in this game's roster of possible connections. Now, if the server disconnects, and that happens all the time for reasons we may never hear about, that just ends the game. You're playing with somebody over in London has the server goes down, there's nothing left to be done. So we end the game. Just try and handle it gracefully. These things will happen all the time, so prepare for them. Now, Steam uses lobbies for this stuff. So for Steam, we have lobbyjoined.connect. This happens when you join a lobby. It receives several parameters. The first one's the new lobby ID. I like to actually spell that out, just so I remember what it is, rather than just using an underscore, as that has special meaning. Permissions is always 0, as I recall. It's kind of reserved. This is more or less very nearly a clone of the direct C++ level Steamworks API. They have permissions in there. I don't know what it was supposed to be. They never used it. Now it's just supposed to be 0. So we put the underscore there, so Godot doesn't nag us about having a parameter we're not using. I forgot what locked stood for, but I knew it wasn't something we needed to worry about here, so that's underscored as well. Response is how the attempt at lobby joining worked out. That's an int that has special meaning, very clearly defined in the Steamworks API. I prefer to check it against the actual enumeration here rather than the integers, because I'm trying to communicate to other people and sometimes myself down the road here. I may not always be clear that that 1, which is chat room enter response success, is what I'm looking for here. And a lobby is very much like a chat room. I don't know that it's the best description, but it's in the Steamworks API declarations now, so it's what we're using. So on success, our lobby ID is the new lobby ID. We know we're connected. The next thing we do, and this is important, is we get the Steam ID of the lobby owner. That's the person who clicked on that host lobby button. The Steam ID is how we find their ID. And we have to verify that it's not our own here. I really need to emphasize this. The downside to working with Steam networking is you do need 2 machines to do it. There's no way to work around it. You might be able to get around it with a virtual machine, but that's putting a lot of taxing on your own machine too. So we check on that first. If it's not the same and we know it really is somebody else, we call connect Steam socket with the ID. This is something I wrote, which I will go over momentarily. Register the player on everybody. You'll note that that is RPC, not RPC ID, with their chosen name. And updates locally the players list with your unique ID, your peer ID, set to your name. Let's look at Connect Steam Socket before we go into error management. This is perhaps the most important part of getting high-level networking from Godot working over Steam. You have your Steam ID of the person who is hosting this lobby. You create a new Steam multiplayer peer, and then you call create client on it, which I should note to you is Steam multiplayer peer direct. This would not show up for eNet, I don't believe. With their Steam ID, and then 0 in an empty array. The 0 is a local virtual port, effectively. I have not yet thought of a reason why I might want to use it, but conceivably somebody might want a virtual port in here. It's not something we're really going to want to worry about. Options is an array, which I'm sure is documented in the Steamworks API. I've never needed to put anything in there. Then lastly, we set our multiplayer peer to that peer. So it all goes on in create client with that Steam ID after you get it by getting the lobby owner. This is 90% of what you need to take away from this tutorial if you've never done Steam before. It doesn't worry about IP addresses. It doesn't worry about ports or sockets. Well, it does, but not on the surface. You just need to get that ID, and it's the ID of the person who owns the lobby, who created it. So for create Steam socket, I just described connect instead of create, didn't I? I am so sorry. But yeah, for create we do something almost the same, except we call the multiplayer peers create host. No, I did this in the right order. With, again, 0 and empty array or whatever it is you want to put in there. That's going to be very much up to you. This will cover it most of the time. And then we set our multiplayer peer to it, which is a very important part of it. So this is how Steam's lobbies connect you to the other machine without you having to know what the exact socket is for that machine. So let's wander back up here. So that's basically all we need to get HLN working there. But, you know, what if we get a response that's not the success? The lobby joined is called during an attempt to join a lobby. I should clarify. It's not just when you get into the lobby. It's when you tried. And if it's anything other than chat room enter response success, or 1, you're going to get a fail reason. I don't know that I really care for this being all caps here, but that's another thing that survived from the original version, which can be a number of thoroughly declared enumerations, all attached to Steam here. Maybe you blocked a member, maybe one of them blocked you, maybe you've been banned, or they're full, or maybe it doesn't even really understand what happened, but it definitely means that it's not letting you in. All a possibility. So times like that, I will omit that fail reason to the log. In fact, I could probably Control-R replace that with something that's better formatted than capital fail reason. If the lobby is created, then you don't need to worry about joining it because it's practically local. But you will be taking a status on attempting to create it. And remember, that's what these Steam signals are. They're attempts. don't necessarily mean that they succeeded. That's different from some of the others. It takes a status and the new lobby ID. If the status is equal to 1, which honestly could probably be a response to, like response success here, and they've probably got a specific one for creating it. I'll have to come back to that. Lobby ID equals new lobby ID is something I used to have there, but is apparently not necessary. So for brevity, I've dropped it out. Then it sets the lobby ID, lobby data using that new lobby ID by setting the key name to, in this case, your persona name, Spectabulous Test Server. You can replace that with whatever string you want. Then it creates that Steam socket. After setting the data, creates the Steam socket. As a reminder, that's enet. There we go, just passed right by it. That's where we call create host and set multiplayer peer, and setting all of that up. We just pack it into its own function. Otherwise, it emits an error on creating lobby. I honestly would prefer for this to be as detailed as this is, but failing to create a lobby is not something I've had a lot of issues with. Under process, of course, we have to have steam.run callbacks. Now, this doesn't have to be here, it just has to be somewhere. In fact, depending on the Steam callbacks you need, you may not even need to run it every single frame. It's usually a good idea to. But that's all we really need in our process function for game state. We already went over register player and unregistered player. Let's jump down to begin game. Now, begin game is meant to be called on a server, but it's not an RPC. So I've got an assertion here just to tell me if for some reason I'm calling it on something that is not the server, which would mean that there's something very wrong with my code and is a good time for an assertion error. I don't want clients calling this without any kind of synchronizing with the server. After that, we called loadworld.rpc on all clients, so this gets called on everybody. And all that basically does is set up the scene. It instantiates the world, adds it as a child, hides the lobby, and unpauses, and that's all we need to worry about here. Your ultimate design might have something much more intricate and detailed in there, but my whole point is to keep this simple. After that, we grab some references to our player scene and our world node, and set a basic iterator spawn index. This can be colon equals because we want it to remain an int, which just keeps track of where our players are being spawned. And there are 12 spawn points, 12 players. That should work for now. This is just an example of one of those cases where I wanted to make sure that the right number was coming through. I don't need to have a print there. So, we have our players already populated at this point, that dictionary. For each peer ID in the players, we create a new character body 2D player, set its player name to the name in players that's associated with the peer ID. This could be much more complicated if you've got additional data in there, which I imagine a lot of us will. But you get the idea. Now next up is getting the players node, which is where we add all of the players. Let me jump over here real quick. Every player is going to be a child of this, and we add player as a child to it, but I want to call attention to true here. There's a possibility, actually no, this is almost a certainty, that these players are going to be created with the same initial name. That's a big problem for two siblings to have the exact same name in Godot. It will cause dysfunctionality in the best case and a crash in the worst. By putting true at the end, it ensures that on adding it, it will have some kind of a reasonable and unique name that is not shared by any other sibling nodes. So in this case, we do need true here. After that, we need to set the authorization for changing things for the player so that everything is synced up properly. So that's player.setAuthority.rpc with its peer ID. What is setAuthority? I actually wrote that one. Let's take a look at it. Here we go. Now, it looks very simple. It's just any peer and call local. In fact, it could possibly be much more restricted than that. And takes a peer ID, returns nothing, and calls set multiplayer authority with that ID. So you might be thinking, okay, well, that's interesting, but why don't we just call it here? Why are we RPCing it in? Authority is something which, unbeknownst to many, actually also has to be synchronized. It can be uniquely different across machines on the same game, and it shouldn't be because it's going to cause all kinds of issues if it is. So I always try and set that from within its own script, calling an RPC. So everybody ends up setting authority to the same ID on their local machine. I also remind you that this is RPC, not RPC ID. It's not just on their machine, it's on everybody's. But it's taking their peer ID. Next up, you'll note that we have all these 12 spawn points here, each in a different location. We grab that location with this little bit of convoluted code, I wish I'd kept simpler, and call a teleport function. Now, I think I may have mentioned earlier, player's position is synchronized, right? So why don't we just set position and expect it to synchronize there? Well, once again, that's a question of who has authority over it. If you set it on the host, but only the client has ultimate authority over its position, then you will have one frame of it in the new position before it gets snapped back to where the client put it. So teleport is a name I chose to avoid things like set position or set location, as I find them to be a little overused and less descriptive of what I'm trying to do here. It is a basic setter though, sets the position to new position, returns nothing. Any peer call local. But the catch is, this is all being done on the authorized client, not on somebody else, not on the host. It happens there. And when we do that, the synchronizer will duplicate this position across all other machines, rather than duplicate over it. So that was another thing that had to be an RPC. This is the thing that tends to throw people off when they make a network game for the first time. It does come up with time, though. After that, we increment our spawn index. One sensitivity here is we'll run out of spawn indices at 12, so if we have more than 12 players, we're going to have an issue. But that's our maximum number of players anyway. I don't really like having it tightly coupled like that, but this will do. And that was back in game state, yes. So I described these guys before, create Steam Socket and connect Steam Socket. Let me do it one more time, just to really drive it home, because it's got to be the reason the vast majority of people are watching these videos. You create a new multiplayer peer that's a Steam multiplayer peer. And if you're creating the game, you do create host with 0 and an array of options. I've never had to put anything in. And then you set your main multiplayer peer to equal that peer. If you're connecting to it, the only real difference is you're using connect client, and you need that Steam ID of the person who decided to create that socket. And this is actually socket work under the hood, but Steam insulates you from all of that. Because, let's be honest, you've got enough to think about. A few functions here which could stand to be in utilities instead. Alright. So after that again we have create enet host and create enet client. I admit I'm not entirely sure that these really need to be in game state, as they very much encroach on lobbies territory. but for the moment they are. So let's go over them again. If you're using eNet instead of Steam, it creates an eNet multiplayer peer, calls create server on it with that default port we set up, that's 10567 I think, sets your player name, remembers to add you as the host to players, as that does not happen automatically here, and then sets the multiplayer peer at the very end after configuring it. If it's a client, then you do create client with the address and the port, that's your socket again. Sets your multiplayer peer, awaits it connecting to the server. This is a little different from connect Steam socket up here. So you need to make sure you are connected before you continue. Then once connected to the server, you can RPC everybody else, so you register your player. Then add yourself to the list with your new player name, because that would not have been called there. Lastly, my utility functions. I'm not even sure I'm using all of these anymore, but make string unique simply takes the string you want and then iterates over it and attempts to find out if there's any number after that could be appended to the end of it which hasn't already been taken by somebody else. This is probably a bit sloppy for synchronization, but it should do the job. Get player name is an RPC which simply returns your player name in the player list. I'm not sure if I still use it or not, honestly. Is game in progress in this case, I talked about this earlier, it just tells you whether your game is currently running or you're back at the lobby screen. This is going to be different from everybody. Here I went with the original check, which was whether you have the node of world on your scene graph route. There could be other things here too. If you want to have like a boolean that says whether the game is running, that's fine, but make sure it's synchronized properly. Otherwise, one client will think the game is still going, another won't. The server will have its own idea, and it'll just scatter. Endgame first checks whether the game's in progress, and if that's the case, it removes everything you've got up here. This is just freeing this here. This emits the game ended signal, which we could attach to whatever we want, and then it clears the players list. So that basically resets us back to the very beginning. And that is how game state works. The majority of the work here is between lobby and game state.